Hello and welcome back to the channel. It is another video of our Explainable AI series, and now we'll start DALEX, which is another model that lets us zoom in and X-ray our black box of advanced machine learning or artificial intelligence models. We'll use DALEX in 3 videos. The first one, which is this one, will be on driver analysis. The next one will be on model performance. And then in the last one, we'll have a look at the local interpretability behind DALEX. Our machine learning model of choice will be XGBoost. If you're interested in learning more about XGBoost after we do this tutorial, then I suggest that you have a look at my Udemy course, in which we go end-to-end into the implementation of XGBoost, where we do as well the hyperparameter tuning, which is key in order to do any kind of machine learning model. The first thing that we need to do in this tutorial is to install DALEX, so pip install and then DALEX, and here we go, actually in small letters, and let's do Control Enter. And while it runs, let me also go through what this can do. So DALEX, it's also in a way very similar to SHAP, because first it also looks at the local interpretability, and then the second one, it also looks at the global interpretability. But what else is there? First, we can have a look at the model performance, and this is something that I find to be very, very exciting, because not only are we studying the variables, not only are we studying the predictions, but also we'll be studying the model. On top, I find that all in all, the visualizations are a bit more intuitive than SHAP, which in a sense is far better when you are to present this to your stakeholders. Now that this is done, what we need to do is that we need to import some libraries. So import DALEX as DX, then we import XGBoost as XGB, and then the last step is to then import pandas as PD. And here we go. Let's do Shift Enter to go to the next column, and here we load data. And how to do this? So data equals to, we go to our DALEX, so dx dot datasets, and then we do dot load Titanic. So we're going to use a very famous data set, so who survived in the Titanic tragedy. And let's also have a look at it. So data dot head, open parentheses, and again Shift Enter. And here what we see is, for instance, the gender, the age, the class, and of course whether they survived or not. The next step is that let's transform this, for instance, the embarked, into dummy variables so that it can be fed into our machine learning model. So let's put data prep as another section, and here we go. And so transform into dummies, and it's super simple. So data again, so PD for pandas dot get underscore dummies, and then inside include data, and then we include drop first equals to true, and this is so that we don't fall into the dummy variable trap. And then if we are to have a look, so data dot head again and Shift Enter, and what we see is that of course we'll have the class second, class third, then also have the crew deck, engineering, and so on. And now our data set is actually much bigger. The next step is to isolate the X and Y. And here we go. Again, it will be fairly simple. So Y equals 2, and it is our data dot survived, because that is our dependent variable. And then we'll have that our X equals 2. We go to data, and then we drop the survive. So drop, and then columns equals 2, and then we just write survived. And here we go. Let's do Shift Enter once more. So now that we can go to our next step, and let's put in the text over here. Let's do XGBoost, and the first thing that we need to do is to set some parameters. And let's go all the way down, and as a comment, parameters, and here, so params equals to, and then we open the curly brackets for this dictionary type, and then we include the objective. The default in XGBoost is a regression type of problem, and as a result, because it does not detect this difference between binary and regression, we need to tell it. So we just include objective, and then we include binary, and then colon logistic. And here we go. And then the next one would then be to be the eval metric. And here we would just do again on the right. And let's do the AUC. Of course, we could have also used the F score, but I'm actually not sure if we have an unbalanced data set. So let's use the AUC. And the next step is to create an XGBoost matrix. And this is so that we prepare our data in a format that is accepted by XGBoost. So XGBoost Matrix. And inside what we do, so we'll call it train equals to, we use our XGB library, and then D matrix. And then inside, first we include our X, and then we include a label, which is the dependent variable, which is our Y. And again, oh, I don't think we run the first one. Let's run the second one as well. And again, shift enter. And here now, yes, we create our XGBoost model. And then here, so it's super simple. So model equals to, we use our XGB library, and then we train based on first the parameters. So we can see here params equals params. And then the second one is the dtrain. And the dtrain is actually our train that we have just created. And let's do Control Enter. And let's now create some more text, because now it's finally time to start our DALEX. And as you are most likely accustomed by our previous tutorials, we always start by creating an explainer object. And what can we do? So create this explainer equals to, and then of course use the DALEX dot explainer. And then inside what we include is first the model, and then we include our X, and then we include our Y. So super simple, shift enter. And here we see the preparation, and let's take that down so that now, and we are going to do two things. The first one is we are going to have a look at the driver importance, and then we are going to study the linearity of our own drivers. So here we go. So driver importance. And here what we do, we use the explainer that we have just created, and then we look at the model parts. And here we go. So parts, and then we open parentheses, and then we just plot. And here we go. So let's do Control Enter, and let's have a look to what we get. So we have here the booster, and here we see what are the most important drivers when it comes to understanding who would actually survive the Titanic. And here we see that it will be the gender, the most important. Then we'll have the third class. Then we'd have the age, then how much people paid, and so on. So these first four, for sure, they are very important in order to study how relevant it is. But all in all, this actually does not tell us in which direction. So gender male, but is it because they're male or because they're not male? When it comes to third class, it's because they are part of the third class, or the other way around, because they are not. And this is something that we need to understand better. And as a result, what we want to do is to study the linearity of the drivers. And again, it's super simple. We go back to our explainer object, and then we look at the profile of our model. So model profile, open parentheses, and then we plot it. And let me do this another way. So on the right side of the parentheses, we do plot. And here we go, Control Enter. And here we see all of them. So For instance, let's go to the very top and let's dedicate. So age, so if they are very young, then they're very likely to have survived. And we can see that it goes down with age. So older people had a lower likelihood of surviving. When it comes to the fair, we can see here that if the fair was lower over here, so especially, so if it was like, 5 or 0, apparently it's fine probability, but if it was like on a very low fair, then the probability of surviving is lower. If we have a look, the other one was gender, so if they are male, they have a lower likelihood of surviving versus not being male. And for instance, we have the third class, so if they are part of the third class, then again, they have a very lower probability. And I think it really helps that when you over the line, you get the prediction and then you compare it versus the mean prediction. So you can have this benchmark comparison. And you can do this for every single one of them. And this is something that I honestly think it's quite helpful. And it does feel that it is a step forward versus what we saw previously in SHAP. As a result, we're actually done with this video. I hope you enjoyed it. And I'm very much looking forward to seeing you in the next one. Until then, have fun.